Hi everyone, my name is Rahul and I am going to be a junior at Doherty Valley High School. And my starter project at Bluestamp was the Simon Says game, and my intensive project, as Liam mentioned, is the autonomous irrigation controller. And the reason I chose this project was because I really wanted to challenge myself with a project that had minimum documentation. But I also wanted a project that had some real-world application. And as you know, there's been a drought in California for a very long time, and I wanted to create a way to save water for my plants in my garden and for other people. And so the way my project works is it takes readings from the soil moisture sensor, and it sends it to the Arduino and tells it to either turn the solenoid on or off. And so this is our makeshift watering system that is only for testing purposes. And as you can see on this display, it says that the sensors are not in soil, which means that obviously it's not in soil, so I won't get accurate readings. However, once I put the sensor in, this is dry soil, it'll read the data a few times. And it'll turn the solenoid off. I don't know if you could hear the relay trigger, and basically it allows water to go through. And so basically the way my project works is there's I guess 5 key components. I have an Arduino, XP, a relay, a solenoid, and this moisture sensor. And so the Arduino takes all these components and basically coordinates all their functions. It's basically the brain of my circuit. This moisture sensor works by taking in input and returning a value between 0 and 1023. And it basically does that by measuring the resistance between these 2 probes. And I'm able to take that value and determine the water level from there. And so once I determine the water level, I tell this solenoid valve to either turn on or off, and it's controlled by this relay. A relay is basically a switch, which is similar to a transistor in that I can turn, for example, the solenoid on or off without manually pushing a button or a switch. And then the last important part of my project is this XP chip. So I have one on each Arduino in each box over here, and all the information that's from here is sent to this Arduino wirelessly through the XP, and therefore I can display the information on my LCD. And so 2 of the main, I guess, challenges I had with this project were, first, I found that the soil moisture sensor didn't have a very high resolution, which is basically the range of values it returns. So instead of returning 0 to 1023, it would return 0 to 400. And so sometimes that would give me inaccurate reading or outliers in my data set. And to avoid this, what I decided to do was read the values from the moisture sensors 5 times and then average that data and then return it, so that outliers in the data set wouldn't impact what's happening in the system as much. The other major issue that I had, which actually took a while to figure out, was the Arduino was constantly resetting because it was drawing a high current from the solenoid valve, and because of that, the system wouldn't work, obviously, because it would reset. And this is actually caused by a voltage spike, which is also called flyback voltage. And in order to fix this, I added a diode on the solenoid to allow the current to continue to flow, and then eventually it'll die out. Yeah, and so I guess being at Bluestamp has been a great experience, and I learned a lot about electrical engineering, computer science, designing circuits, a little bit of mechanical engineering, and I also learned as important as it is to know how to design circuits and how to build products as an engineer, it's equally as important to know how to solve problems and be able to persevere even though you get stuck or have to go through obstacles. Thank you.
Does anyone in the audience have questions?
How did you know that you needed that other node after the solenoid was giving you low readings? How did you know to find that out?
The diode?
The diode.
Oh, well, so
Is it an extra sensitive diode, or is there another? Could you have chosen a different pronged?
are you referring to the moisture sensor?
Yes.
Oh, well, basically, I was able to collect the. Wait, so are you asking if?
Why not pick a different moisture sensor for
Oh, because
redesign the sensor?
although the resolution was between 0 and 400, I was still able to like decipher between like moist soil and dry soil, and so that's all I really needed for the project. I could have ordered another sensor, but there's no way to know if that sensor would have a higher resolution or lower resolution.
Actually, I have a question. So it seemed like he was sort of going in direction initially with diode, but how did you identify that you needed that protection diode?
Actually, this is what I was talking about, like problem solving and getting over obstacles. Basically, I spent a very long time trying to figure out this issue. I did a lot of research, and I came across someone that was having a similar problem over Arduino forums, and I was able to use his issue and apply it to my own and just fix the problem.
Okay.